Hey, good morning. This is Lee Swanner with Swanner Landscaping and Irrigation. This is the second video in the irrigation design series that I'm doing. And the first video, we defined what static pressure is. And we define that as the pressure within a system when the water's not moving. So that's what static pressure is. And we also defined briefly what dynamic pressure is. And dynamic pressure is the pressure along points in a system when the water is moving. So dynamic pressure accounts for friction loss within that system. So you've got your source, pumping station, water tower, whatever it might be, and it's when that water is static within that system, that's your static pressure. And when it's moving, we have dynamic pressure. And so we're concerned about static pressure and dynamic pressure, but what we want to talk about is what is going to limit the size of our zones. And we have three limiting factors. The first one is that static pressure, because that's our starting point. That's where we have to start, okay? Because everything that we build into our system, as the water moves through that, it's going to reduce the pressure because there's going to be friction loss through the backflow, through the valves, through the pipe, through everything. Okay, so we have to take those things into account, but there are three primary things that are going to affect what we have to work with. And those are these three limiting factors. The number one is going to be the static pressure. Number two, the second limiting factor is very important, is your meter size. So in most residential applications, you're going to have three different size meters. A lot of times it's 5/8 meter, sometimes it's 3/4 meter, and sometimes I'm so happy when I lift up that meter box and look in there and it's a 1-inch meter because I know I've got plenty of water to work with. But a lot of times it's going to be 5/8 and a lot of times it's going to be 3/4. And so you're limited by the amount of water that can be forced through a 5/8 inch meter or a 3/4 inch meter or a 1-inch meter. And the more you try to push through there, the greater that friction loss is through that meter. And it's a significant amount. And if you start off with a pretty low static pressure, you've got to make your zone sizes small. So we're going to get into all that, but we got to understand that concept first. So we've got our first limiting factor, static pressure. Second limiting factor is the meter size. And so I'm going to help you out a little bit. So on a 5/8 inch meter, you can get about 15 gallons a minute through a 5/8 meter. So so you know you got that to work with. Through a 3/4 inch meter, you can get about 22. This is with respect to the friction loss too, because if you try to push more water through there, you're going to have a lot greater friction loss. So a 3/4 inch meter, you can get about 22 gallons a minute through that. And then a 1-inch meter, you can get about 36 gallons a minute through. And so anytime you lift up your water meter and look in there and it's a 1-inch meter, man, you know you got some water to work with, and that's awesome. Okay? But there's a third limiting factor that is vitally important, and it can come back to burn you so many times if you don't account for it. Because you can read your static pressure with your pressure gauge on the house. You can open up the meter box, look in there and take the little cover off and clean off the mud off of it and look at it, and it's 5/8, 3/4, 1-inch. So you've got those two pieces of information. But the third limiting factor is going to be the service line size. And I can tell you this, I've done my design based on this, assuming that my service line was a 1-inch schedule or a 1.5-inch schedule, and it'd be 1/2-inch copper tube. Okay, it's been there for 50 years, and for whatever reason, they put in 1/2-inch copper pipe. And let me tell you something, you cannot get water through a 1/2-inch copper pipe. I mean, you can get some through it, but you ain't gonna get what you need. And if you design your system and you don't take into account that service line, especially if it's a long ways from the meter to the house where you're tying in, you are going to get spanked, man. And I'm telling you, it sucks because you've already designed your system, you've already put it in, and you crank it up and nothing happens, or a little bit happens, and it sucks. I'm telling you that. So be very aware of that. You're going to need to dig up that service line in front of the meter, or dig it right there at the corner where it comes to the house, and make sure that you account for that, because the friction loss on a 1/2-inch pipe or 3/4 copper line or a 3/4 scheduled pipe, it is going to screw you bad, and I'm telling you, you don't want that. So those are three limiting factors: the static pressure, the meter size, and your service line. So if you have a copper service line, a 3/4 inch scheduled service line, you're going to have to tie in up as close to the meter as you can and come back with 1 inch pipe or 1.5 inch pipe or whatever your design is. But we're going to get into all that. So there you go. That's the second part. We're going to take this in little bite-sized pieces so we can this is just the way I was taught, and this is the way I'm going to teach you. Static pressure, meter size, service line. All right? We'll see you next time. Thanks.